When beginning our project of building a coil gun with up to 3 capacitors and 1 battery, we began by taking apart the camera to learn how the circuit worked. We quickly learned that the capacitors charged and when discharged set off the flash of the camera. This would be what we would use to set off the gun. We then added capacitors and played with the design until we were pleased with how it looked and how it worked.
The materials used to make our coil gun include a circuit board from a disposable camera along with 2 extra capacitors. We took apart an ink pen and used the outer cartridge as our barrel. We attached 2 washers to the pen cartridge to hold the coil in place. Next, we stripped telephone wire and wrapped it around the barrel between the 2 washers to make the coil. For ammunition, we took apart a shotgun shell and used the steel pellets. We used 2 light switches to charge and fire the coil gun. Last, we placed our coil gun in a Tupperware container to hold everything in place and protect us from getting shocked.
To make our coil gun work, we all know that you need an induced current through these wires around our solenoid to launch our projectile out of our barrel. To do that, we start with a 1.5 volt battery. From there, the current runs through to our first switch, which is located on the right, to control the charging of our capacitors. From this switch, the current then leads back to our circuit board here, and then it is run through a series of transformers to step up the voltage, and then from there it charges our 3 capacitors, which we have wired in parallel. From there we have a switch wired to one side of the capacitors, which is the switch on the left, which is what we use to discharge the capacitors or to fire the coil gun. From there it runs through this wire through the coil, creating the magnetic field to launch the projectile, and then from there it circles back to the battery and the process is complete.
Alright, so these are the coil gun calculations. First we're going to go over what we know. We know the mass, which is 0.25 grams, the volts on the capacitor, which is 300 volts, the capacitance of our capacitors, which is 100 microfarads, which when we find C equivalent, we add all 3 capacitors together, so we multiply 100 times 3 to get 300 microfarads. We measured an average X distance that our coil gun shot, and we got that average to be 4.23 meters, and we shot the coil gun at a height of 0.43 meters. So now we go to our unknowns. We need to know time, velocity, kinetic energy, our potential energy, and our efficiency. To start, we use the kinematics equations in the y direction. We know that y final is 0 because it hits the ground. Y initial is going to be the 0.43 meters that we set our coil gun at. Vy initial is going to be 0 because we're shooting our capacitor parallel to the ground. And then it's minus 1/2 times gravity times your time squared. So when you solve for time, you get t equals the square root of your initial height divided by 1/2 gravity. So we got t equals 0.43 meters divided by 0.5 times 9.81 meters per second. And take the square root of that and you get t to be 0.2961 seconds. Then we go to our kinematics equation for the x, and we get x final equals x initial, which is going to be 0 because you set your coil gun to be the 0 distance at the start. Then you add the velocity in the x direction times time. So when you solve for the velocity in the x direction, you get that equals your final x distance divided by your time. So we got our average final x distance to be 4.23 meters. So we divide that by our time we got from the first equation, which was 0.2961 seconds, and we got that to be 14.286 meters per second. So after we find that, we come down to we want to find the efficiency next. So we're going to compare the kinetic energy of our coil gun to the potential energy stored in the capacitors. So the kinetic energy of the coil gun equals 1/2 mv squared, so 1/2 times 0.00025 kilograms, which is the weight of our BB, and then we multiply that by 14.286 meters per second, and we square that. So we got our kinetic energy of our coil gun to be 0.0255 joules. Next, we're going to find the potential energy stored in the capacitors. So that's going to be 1/2 times the capacitance times the voltage on the capacitor squared. So that's 1/2 times 300 microfarads times 300 volts squared, and that gives us 13.5 joules. So to find our efficiency, we take the energy from our projectile and divide it by the energy from our capacitor, multiply that by 100, and that gives us a percent. So that was 0.0255 joules divided by 13.5 joules, multiply that by 100, and you get your efficiency to be 0.19%.
In conclusion, our coil gun, we believe, is basically an ideal design. It incorporates 2 light switches that help to keep the person shooting the gun safe. It is in a box, that way no one can accidentally discharge the capacitors and get shocked. It makes it tidy, and overall it performs fairly well. A few things we learned from doing this project are we much better understood how a coil of wire can have an effect on a projectile inside of a barrel, and we also better understood how capacitors work, how they can store up a tremendous amount of charge and voltage on such a little device. And we also learned about circuit boards on a disposable camera. We had to figure out what actually did what on the circuit board, as in what discharged the capacitors and what charged them, and then we had to wire all that up to our switches and get all that working. So overall we learned many things, and it was all applied physics that we learned in class.